This is some kind of rocket ship or something, and it's holding a whole lot of jet fuel inside of it. And it's not going anywhere, it's just sitting there with zero velocity. The jet fuel inside it has zero velocity. And then that jet fuel is ignited, and it is turned into gases that are shot out of the back of this shippy thing at a very high velocity. How did the momentum of the system of the rocket ship plus the gas inside it change? Not at all, because there were no external forces that acted on the jet plane or the rocket fuel. It was an internal force that blew the gases out the back of the engine. Sure, now there's gases going at a high velocity with some magnitude of momentum, and the jet ship is now moving forward with some magnitude of momentum in the other direction. But overall, this system of gases going one way and jet plane going the other way, overall this system has a momentum of zero, because the momentum in the left direction cancels out the momentum in the right direction. And the momentum of this whole system is exactly like it was when the ship was just sitting there, not moving at all, and the gases inside it were not moving either, which is zero. The vector quantity of the momentum is zero. Almost an identical example here. Exactly the same story. We have a gun with a bullet in it. Neither the gun nor the bullet are moving. They're just sitting there. Velocity zero. Therefore, the momentum of the gun plus bullet system is zero. Then there is an explosion inside the gun, and gases plus bullet shoot out at a high velocity, and that is an internal force. There's no external force acting on this gun plus bullet system, so the momentum of the gun plus bullet system cannot change. It must still be a total of zero. And if there's a bullet flying with a velocity to the right, that means the gun must have some kind of momentum to contradict that, to counteract that bullet's momentum. So the gun must have a velocity now a little bit to the left, and that's the recoil velocity. So you can think of the bullet propelling the gun just like the expelled gases created a thrust to propel the rocket plane. So knowing that, here's how we would approach mathematically a problem where we can figure out the recoil velocity of a gun. We know that the momentum doesn't change because there's no external forces. So even if the momentum wasn't zero to start, we could come up with this equation. The initial momentum of the system is equal to the final momentum of the system. And in this case it just happens to be zero for initial and final. But regardless of what it is, we would write, and we know that momentum is mass times velocity. So in this gun and bullet situation, we have the initial momentum being mass times velocity of the two things that are involved in the system, which are the bullet and the gun. So we have to do some subscripts here. We have an MV of the bullet and an MV of the gun. Let's call the bullet B, and we have to show this is the initial mass and velocity of the bullet, and then over here is the mass and velocity of the gun, and it's also initial, so I'm going to put little i's there also. So we've got PI there. PF, the momentum final. Now is when we really need to separate the MV for the bullet and the MV for the gun, because now they're going at different velocities. So again, we'll have this be the mass of the bullet after it's fired, so be final, and the velocity of the bullet after it's fired, which is VBF, velocity final, and then this is the mass of the gun, final, and the final velocity of the gun. Now we know here that the mass doesn't change, so the I and F subscripts for the mass aren't really entirely necessary, but why not? Now let's figure out the numbers here. We know that the initial velocity for both the bullet and gun is 0, and that makes the whole term mv equal to 0 for both of these terms. And it's just like we said, the initial and final momentum is going to be 0, because initially neither of these objects had velocity. Alright, let's continue on the next page. Remember this equation. The left side we saw was 0, and on the right side we had mv of the bullet, which is a mass of 0.02 kilograms is the m, the v is 620 meters per second, and the mv of the gun, its m is 5 kilograms, and its v is, we don't know v. That's because that's the variable we're solving for. So it's good to have that there. And now we can just solve for the v, which is what we want to know. 0.02 times 620 is 12.4. And I'm going to subtract both sides, subtract 12.4 from both sides to get negative 12.4 on the left, and leave 5v final on the right side. Then I'm going to divide both sides by 5 to solve for the final velocity of the gun, which is negative 2.48. Reasonability check. Does the negative here make sense? Yeah, it actually does, because velocity is a vector, and it's telling us that the velocity is going in the negative direction, which we implicitly assigned to be the left direction when we said that the bullet was going a positive velocity in the right direction. What I'm saying is, if the bullet going right is going at a positive velocity, that means the negative direction for velocity must be left. And we would actually be worried if we didn't get a negative number for the velocity of the gun, because we know it has to be going left. It's going to be going the opposite direction than the bullet goes. And second part of reasonability check, what is the magnitude of this number? It's a lot smaller than the velocity of the bullet, which is what we'd expect, so we're good to go.